Good morning, friends. Myself Chandu Potangali, New Arts Commerce Science College, Shoga. Uh, we'll be starting today's lecture. Let's recapitulate the things that we have learned in the last few lectures. Since last few days I was busy, so I was not able to contact you. But I'll assure you that henceforth we'll be having the uh, regular lecture. So we started from the chemical energetics. We have seen the chemical energy and other form of energy. Then we have seen the different statements of the first law of thermodynamics. Then we have seen the open system, closed system, isolated system, system and surrounding, definition of system, definition of surrounding, etc. We have seen the different processes, isothermal, isobaric, isochoric, adiabatic, cyclic processes. We have seen the function, state function and path function. What is meant by function? That also we have seen. We have seen the phase and different phase of the systems, homogeneous and heterogeneous phase. We have seen the properties that are the extension and intensive properties. Then we have seen the sign conventions that are used in the chemical energetics or in the first law of thermodynamics. Then we have seen the limitation of the first law of thermodynamics. Then unit of the unit that are used in the thermodynamics and their interconversion that we have also seen. Please remember that the problem or question may ask on the unit conversion in the exam. So this part is important, units and its conversion. Then today we will see the what is the standard state. What is the standard state? Standard state or standard temperature pressure. Standard temperature pressure. Standard state. Uh, the temperature at which 273 273 273.15 plus 25 degree centigrade, that is room temperature, that is equal to 298.15, and this is temperature, and pressure is equal to 1 atmosphere. 1 atmosphere is called as the standard temperature and pressure. Standard temperature and pressure, 1 atmosphere. This is called as the standard temperature and pressure. The 25 degree centigrade, that is 298.15 degree Kelvin, and 1 atmospheric pressure is called as the standard temperature and pressure. Now today's lecture we are going to see about the enthalpy of formation and standard of formation. Enthalpy of formation and standard enthalpy of formation. Here it is, standard enthalpy of formation. Enthalpy of standard enthalpy of formation. So heat of formation, here it is, heat of formation or the enthalpy of formation. Enthalpy or heat of formation. Enthalpy of formation or heat of formation is what? The heat change that takes place when 1 mole of substance is formed from the elements under the given conditions of temperature and pressure. Remember that the heat change, heat of formation, we are defining the heat of formation or enthalpy of formation. Enthalpy of formation is also called as the heat of formation. Enthalpy of formation or heat of formation. Enthalpy of formation is also called as the heat of formation. Remember that enthalpy of formation or heat of formation. Enthalpy of formation or heat of formation, the heat change that takes place when 1 mole of substance is formed. 1 mole of substance, we know the molarity and normality. 1 mole of substance formed from the elements under the given conditions of temperature and pressure. At that temperature or at that pressure, that is called as the enthalpy of formation. So what is the enthalpy? We have seen the definition of enthalpy. That definition we have seen in the 12th standard. That enthalpy is denoted by H is equal to E plus PV. P into V. E is what? E is the internal energy, P is the pressure, and V is the volume. Or sometimes this enthalpy is written as H is equal to U plus P into V. Enthalpy is what? It is the summation of internal energy plus product of pressure and volume plus product of pressure and volume. Remember that H is equal to E plus PV, or H is equal to U plus PV. That is called as the enthalpy. So heat of formation, enthalpy of formation, heat change that takes place when 1 mole of substance is formed from the element under the given condition of temperature and pressure. That is the heat of formation. So what is the enthalpy? Enthalpy, we have seen the definition of enthalpy. Well, next one is the standard enthalpy of formation. What is called as the standard enthalpy of formation? Right now we have seen the what is the standard and standard temperature and pressure. So standard enthalpy of formation. Standard enthalpy of formation, it is defined as the heat change accompanying the formation of 1 mole of substance in the standard state. In the standard state, which standard state? Temperature is equal to 298.15 degree Kelvin and pressure is equal to 1 atmosphere. Temperature is equal to 298.15 degree Kelvin, 298.15 degree Kelvin, and pressure is equal to 1 atmosphere. 1 atmosphere. That is called as the standard state. So enthalpy, standard enthalpy of formation is what? It is defined as the heat change accompanying formation of 1 mole of substance. When 1 mole of substance is formed from any X element, 1 mole of substance is formed. Suppose Y 1 mole of substance is formed. Suppose Y 1 mole of substance is formed. This Y 1 mole of substance, is formed at the standard state. At the standard state, which standard state? Temperature is 298.15 and the pressure is 1 atmosphere. That is called as the standard enthalpy of formation. Normal enthalpy of formation at any temperature, given condition and temperature, and given temperature and pressure. That is the enthalpy of formation at that temperature. That is called as the at that temperature enthalpy of formation. What is the enthalpy? That we have seen. So this enthalpy of formation is denoted by, so the enthalpy of formation is denoted by delta HF. Enthalpy of formation is denoted by delta HF, standard enthalpy of formation. Standard enthalpy of formation. Simply enthalpy of formation is denoted by HF, or standard enthalpy of formation is denoted by delta H0F. Delta H0F. H0 which indicate that is the STP, standard temperature and pressure. Remember that. Now we have seen the definition of enthalpy. We have seen what is the enthalpy. Then we have seen standard enthalpy of formation. Right. Next example. For example, suppose this carbon solid plus oxygen gas that are reacting and there is a formation of CO2 gas. The standard enthalpy of formation for this reaction is minus 293.5 kilojoule. Minus 293.5 kilojoule. So the delta H0 of the reaction, standard condition, at the standard condition, is equal to sum of standard heats of formation or heat of formation. Sometime before I have told you, heat of formation is equal to what? Heat of formation is enthalpy of formation, right? So standard sum of standard heats of formation of products minus sum of standard heat of formation of reactant. Sum of standard heat of formation of product minus sum of standard heat of formation of reactant. Heat of formation is what? Heat of formation is enthalpy of formation. Heat of formation is enthalpy of formation. So sum of standard enthalpy of formation of reactant. So sum of standard enthalpy of product minus reactant, product minus reaction, whatever value the product have minus the value of reactant, that is the standard heat of reaction. So that can be written also delta H0 of reaction, or sometimes it is written like this, delta H0 Re only, reaction, Re sometimes like this. So delta H0 of the reaction is equal to summation of delta F0 product minus summation of delta H0 reactant. Right. Consider, for example, for the general reaction, let's consider A mole of A, small a mole of capital A plus small b mole of capital B reacts. This capital A reacts with capital B, capital A reacts with capital B, then there is a formation of C mole of capital C plus D mole of capital D, small d mole of capital D. Therefore, this delta H0 reaction is equal to what? These are what? These are the product. Product are what? C mole of C into this number of moles, C into delta HF0 of capital C plus delta plus D into delta HF0 of capital D. What are these? These are what? These are the products. These are the products, and these are what? These are the reactant, right? So a mole of delta HF0 of A, this A, plus B mole of delta HF0 of B. Remember that this is the delta H0 of reaction calculation, that is the standard enthalpy change for the reaction. Remember that standard enthalpy change for the reaction, standard enthalpy change for the reaction, standard enthalpy change for the reaction. Remember that standard enthalpy change for the reaction. It is written if it is written H0, then it means it is the standard enthalpy. It is H0 which is the standard enthalpy. Delta H0 standard, only delta H it is normal, that given temperature and pressure, that is the any temperature pressure enthalpy change, right? But remember that we have to remember this formula for the any reaction. This formula for the any reaction, it is the summation of product delta HF0 of product, that is standard enthalpy change of product, minus summation of standard enthalpy change of reactant. Remember that the elements at the molecular level, that is formation of O2, formation of I2, formation of Cl2, formation of H2, right? And that elemental level, at the elemental level, for this elemental level formation, the delta H for this kind of elements, this kind of stable elements is taken as 0. Remember that delta H or H for such kind of element is equal to 0. Remember that H is what? H is enthalpy. Enthalpy is given by, I have told you since some time before, H is equal to E plus PV. This E plus PV is taken as 0 for the molecular level, for the basic very stable molecular level, that is H2, I2, Cl2, O2, right? If the any substance is having any molecules are having mm, uh, other forms like sulfur shows the different form, sulfur structure shows the different form, then in that case the more stable structure or the most stable structure is taken as the delta H is equal to 0. Delta H is equal to 0. Like the some of the elements show the different structure at different temperature, or the orthorhombic, monoclinic, etc. In that case, the stable structure is taken as a 0. So please remember that this formula delta H0 is equal to C into delta HF. That is, these are the these are the product molecule, and these are the reactant molecule. Product molecule as well as reactant molecule. So these are the product minus reactant. Product minus reactant. Remember that. Next, Next is what? Heat of formation of methane. Heat of formation of methane. Let's calculate the go for the some calculation. Heat of formation of methane molecule. Heat of combustion of methane. Sorry, formation not combustion, because methane is going to combust, and there is formation of CO2. Methane, CH4 gas methane plus two oxygen molecule combines together. There is a formation of CO2 gas plus two molecules of H2O, liquid molecule. So delta H0 for this reaction. Delta H0, it is the standard enthalpy of the reaction. Standard enthalpy of the reaction. Standard enthalpy of the reaction. Standard enthalpy of the reaction is equal to delta HF for CO2. These are the product molecules plus 2. 2 is why? Because there are two number of moles of two number of moles of H2O molecule. H2O molecule. Therefore, 2 multiplied. Here we have seen this A is what? Small a is what? This is a number of moles. Small c is what? These are the number of moles. So here this CO2 is having only 1 mole. Therefore, only delta H0 for CO2. No suffix, no prefix. Sorry, no prefix in the multiplication, plus 2 into delta HF0 for H2O minus delta HF0 for CH4. Only one molecule is there. Therefore, only CH4 into 2 into delta HF0 for O2. 2 why 2? Since there is the two molecules of oxygen. Two molecules of oxygen are there. Therefore, 2 multiplied by delta HF0 are of O2. Now, remember that as I have told you, some basic molecules like oxygen, hydrogen, the delta H is taken as a 0. Therefore, this oxygen will have the 0. So, putting the values of heat of formation in the standard state, these values are given, already given. Delta H0 is equal to delta H0 of the reaction is equal to minus 293.5 kilojoule plus 2y, where there are two molecules of H2O formation. This is talking about, we are talking about, these are the product molecules. These values are for the products, and these values are for the reactants, right? Therefore, this value is already given, minus 293.5 plus this minus 293.5 is what? For what? This minus 293.5 is what? This delta H0 of delta H0 of formation of CO2, and these are the delta H0 of formation of H2O, and this is the delta H0 of formation of, these are the reactant molecule CH4, and as I told you, this oxygen 2 into 0, that is equal to 0. This is for the oxygen molecule. These all values already given, remember that. So summation of the products of the delta HF0 minus summation of the reactants of the delta HF0. Therefore, that comes out to be minus 965.1 plus 74.9, that is equal to minus 890.2 kilojoule. Therefore, this reaction, delta H0 for this reaction, delta H0 for the reaction, given this reaction is equal to delta H0 for this reaction is equal to reaction is equal to minus 890.2 kilojoule, minus 890.2 kilojoule. So in this way, the heat of combustion of the any reaction in calculated, or heat of formation of the any reactant molecules are calculated, right? In the next lecture we will see the more problem on based on this kind of this kind of delta HF calculation, formation delta HF, heat of formation of the reactant, molecules, etc. will be calculated in the next lecture. Thank you.